Good morning. It is Saturday, August 29th, 2015. This is Jason Horak reporting on the ongoing adventures of the Dodge Daytona electric vehicle. Okay, so what we're looking at here at the moment is the NetGain WarP9 motor, which was originally installed in Jack Rickard's Porsche Speedster conversion, his original red Speedster, that he documented in his very first EVTV video. He had it in his car for several years, and then he pulled it out on the show and pulled the bearings and did some work with it, and actually showed the inside guts of it and stuff on EVTV. So this motor ended up kind of being on the shelf there at EVTV, and in 2012, when I was out there at the Electric Vehicle Converters Convention, I had blown up my NetGain WarP9 motor. I'd gotten a rock in it or something, and it tore up the rotor. So that was unfortunate, but I was there at the show, first day, broke my motor. So Jack very kindly offered to sell me his used motor, which he had repainted EVTV Green, and that motor went into my car. I was able to drag race and autocross that year and participate in the parade and other events, and basically saved my bacon so that I could participate in the show. I had given him my broken motor, presumably for experimentation or whatever he was going to do with it, and took this one on home. So it lasted about a month in my car. Once I got it back to New York, I drove it up to the Syracuse airport to pick up my mom, and on the way back it blew smoke out. As it turned out, the motor had heated up to such a point where the commutator had warped, and it caused the brushes to get all torn up, and made the motor, the brushes actually were making a very interesting sound. So the motor still worked. I was able to drive it for a week or so after that, and it sounded kind of like a bicycle with playing cards stuck in the spokes. It was very interesting. Anyway, I took the motor apart. That's all documented on an earlier video in my series here, and took a look at the commutator, found out what the problem was, and put it all back together, shipped it to Warfield Motors, or NetGain, and Warfield out in Illinois, I believe. And they rebuilt it, repainted it back to from the green color into the NetGain red official color during the rebuild process, and I got it back, had new brushes, and worked like a top. So I put it back in actually did a whole process of seating the brushes that had come back, the new ones, again documented in an earlier video, and then put the motor back in the car and drove it for I believe another year. So that would have been from 2013 to, or 2012 to 2013 through 2013. I think it lasted through for EVCon 2013 as well, and then at some point after that, it had started to develop this weird loud noise, possibly early in 2014. I'm trying to recall the timing exactly, but anyway, you can see the video for that. So basically, this motor's been sitting here on my garage floor, awaiting to be returned to NetGain for another rebuild, or a replacement of the bearings, or rebalancing of the rotor, whatever it is that it needs. It does work, but it doesn't spin very freely. So what I'm going to demonstrate here is I've got it hooked up to a 12-volt battery on the right hand side, one of these Metropolitan Industries sealed lead acid batteries that I had in my original EV conversion. I have that battery hooked up to a battery charger on the left, and so that as I'm running it, I could continuously charge the battery. And so for this particular test, it won't really matter, but this is the setup that I'm going to use in a minute for another project. So let me show you just how this motor spins, and you can get in kind of an idea, sort of a baseline of what's going on. So we'll just hook up the negative of the jumper cables.
So as you can hear, the motor is spinning. It's moving along, doing what it does. Now we're going to remove power from it.
And you see how quickly it came to a stop. That's an indication that it's not spinning freely. Like, it's really hard to turn the rotor by hand, and there's definitely something, you know, bound up in there. It could just be the bearings, but it also could be the just the fact that it's unbalanced and is beat up and abused and used in a electric vehicle in a snowy central New York environment. But anyway, so just going to get it rebuilt, and then this motor will be good as new, but I'm going to have to package it up and ship it back to Warfield. In the meantime, I have another motor that is the original. So when this started developing this issue, I had contacted Jack Rickard to see if I could purchase bearings from him, or if he knew exactly where to get the bearings. I didn't know if I was to go through NetGain directly or through a distributor or what have you. So I just contacted Jack and said, hey, you know, what's the procedure for getting bearings for these motors? And his response was that, I'm trying to remember exactly what he said, but essentially that he wasn't sure of exactly how to get the bearings themselves, but he did have a recently rebuilt NetGain WarP9 motor sitting on his shelf that he was looking to part with. He wasn't interested in doing any more projects with that particular motor, and he had ceramic bearings put into that motor. And just as an experiment to see if the ceramic bearings would work better than the original steel bearings and what have you. So that motor, as it turns out, was my original NetGain WarP9 motor that I purchased back in 2010 at the beginning of all this, and it was kind of cool that you know, he had that one rebuilt and it had the new experimental bearings and everything, and so I purchased it from him. So I kind of rebought my original motor, but now after having it been repaired and rebuilt and stuff. So that one he shipped out to me, and I had put that one in the electric car and used that for last year's AvCon 2014, and it worked great. Everything was wonderful, you know, drag race, autocross, all that good stuff, on through the winter and throughout the summer. Recently, it has started to develop an odd, I don't know, it basically sounds like it's struggling, similar to this motor here, in that it's just not as quiet as it should be. You can kind of hear it making grinding noises and so forth, and it doesn't seem to be spinning freely anymore. Again, very similar to what this motor is doing. So it may be that the bearings, those ceramic bearings in this case, have given out as well, or it's binding up in some other way. It does still work. I'm still driving the car every day, but it needs to be repaired, and at a minimum taken out of the car and run kind of like in this setup where it's sitting on the bench, plugged into a 12-volt battery, and I can see how well it spins with no load applied and such. However, since I kind of need the car to work, as it's my daily driver, I'm leaving that motor in there for now. So anyway, in the meantime, what I've decided to do is purchase another NetGain WarP9 motor, and so I contacted my friend Mike at EV Propulsion and let him know that I needed a motor, ordered it on his website, and he's had one drop shipped from NetGain from Illinois directly to me here in New York. So that is this right here. So we have a NetGain WarP9 motor, brand new in the box, hasn't even been opened yet, that will be going into my car preferably before the upcoming shows in September. And the goal is to, have a motor that's quiet, efficient, doesn't bind up and grind and so forth, because, when I'm at a car show and I want to spin the motor up so people can hear how quiet it is, it kind of sucks when it makes metal on metal grinding noises. So anyway, bought a third NetGain WarP9 motor, and so the idea is I will put this in the car and then send the other two back together, since I have to ship them freight anyway. I'll put them on a pallet and ship them, and hopefully that will result in me having a new motor in the car that'll last me a year or more, and then I'll have two motors on the shelf, spare rebuilt motors that are ready to go for replacements and or other EV projects, because hey, you never know, I got lots of Daytonas that need to be converted to electrics eventually, so might as well have a couple motors on hand. Anyway, just kind of wanted to show you the setup here and demonstrate where we were at this moment. I need to unbox the brand new motor and then get that out here so that I can start seating the brushes with my little 12-volt battery. And at 12 volts, it's going to take a while to seat those brushes, so I want to get started as quickly as possible. And now, since the EV is currently in the shop getting painted, is a good time to just start this process. And if I'm lucky, within about 6 days or so, running the motor continuously on 12 volts, I'm hoping that the brushes will be well enough seated that I can put the motor in the car and just be off and running for the car shows the following weekend. Anyway, that's kind of the plan. Let's go ahead and get this bad boy unboxed and we'll get it set up. Alrighty then, so I've got the straps and the staples removed, so let's go ahead and open this box and see what we've got. So this is the direct from Warfield NetGain WarP9, and looks like we got some foam fit stuff going on here, and there she is. A brand new NetGain WarP9. And what's this? Oh, looks like they have sent me a motor-powered NetGain Motors Inc. go-ev.com license plate cover. Well, that's pretty neat. So, looks like it's a little broken there at the top, but I can super glue that. So anyway, so that's the new motor. Got some paperwork here, actual manual. Look at that. That's pretty neat. Didn't get one of those with the previous couple motors. Must be a new thing they're doing. Yep. So there she is. So I'll get it pulled out of the box and put onto my brush seating setup here. Alrighty then. So I've got the new motor unboxed and now hooked up to the ready to go for brush seating. And one thing I wanted to point out was that there are a couple differences on this motor as opposed to the other ones that I've had. The first thing being, it has a nice metal plate on it as opposed to a sticker. They used to have just a sticker on it that would always fall apart and stuff when used in the vehicle. Also, they have the new larger terminals that the other ones were, I think, 3/8, and these are half or something. I don't know. They're much bigger terminals. So I have a little cable here just temporarily. This is a leftover cable from a previous project, which happened to have the larger terminal lugs on it. So I'll be making one that's specifically, exactly this length, and you know, getting it all protected in the special tubing and stuff that I use. But for right now, for this test, at 12 volts, this should be fine, and so forth. Another thing that they have added was they have the temperature probe in the commutator now. So I think that's this here. I got to figure out how to wire that up. Probably find the right, you know, plug connector type thing. Although they look like they're spade connectors, so I might be able to use like a standard automotive spade connector in that and rig up my own little plug. I'd like to use that rather than my temperature sensor that I've just got, like, you know, put into one of the holes and it just touches the outside of the case. This one actually goes in next to the commutator, which would be much more accurate and perhaps useful. I don't know. Another change that they've made is the auxiliary shaft end of the motor is now the same size as the drive shaft end. So it's the larger diameter, which is nice, but it is going to cause me a little bit of heartache because I'm going to have to get a new RPM sensor, because my RPM sensor is the size of the smaller auxiliary shaft. So that is going to be just another purchase. I'm sure they've got one online, either at the NetGain site or through EV Propulsion. But anyway, I'll get one of those ordered and we'll be ready to go for when this motor is ready to be installed in the car. Okay, so we're going to go ahead and hook it up to the 12-volt battery and start the brush seating process. So this will be kind of a baseline of how the motor sounds when it's first plugged in, and hopefully it will quiet down afterwards. Historically, they're quite loud when you first plug them in. So let's go. Well, already it's significantly quieter than the old motor. Let's just take it off here for a second. So it spun for a lot longer than the original motor, and this is with completely unseated brushes, just fresh out of the box. So at this point, I'm just kind of curious. Yeah, I can spin it very, very easily. You know, there is still a little bit of a binding there, likely due to the brushes not being seated yet, but yeah. So anyway, we'll leave a little plastic protector thing on there. You can kind of see it spinning better that way anyway. And we'll go to town. Here we go. And there it spins. So it'll be spinning like this for the next 6 days. I've got my charger on there. Hopefully I'm not blowing up my charger doing this process. I guess we'll find out. Yeah, fun stuff. Alrighty then. So the motor ran for many hours yesterday morning through mid-afternoon before coming to a slow halt. What had happened was that it completely depleted the 12-volt, 120 amp-hour Metropolitan Industries sealed lead-acid battery, even though the battery charger was on it and giving it as much power as it could. Now this battery was purchased back in 2010 and has been in an electric vehicle, has been out, has been used for all kinds of different projects, has been drained down, recharged, etc. So most likely it has significantly less than 120 amp hours of capacity at this point. However, I still expected it to last a little longer with the setup that I had going yesterday. In any case, my guess is that the battery charger detected that the battery had hit a certain low state of charge and then went into sort of a maintenance mode, maybe kicked an internal breaker when the amperage got too high, that kind of a thing. So it stopped charging, the battery depleted, and the motor stopped. Once I unplugged the motor from the battery, the charger was still acting a little funny, so I ended up cycling power on it by unplugging it, letting it sit for a little bit, and then plugging it back in, at which point it seemed to start charging, although the indicator on the front wasn't acting quite right. It seemed to be working, so I just left it overnight and called it. When I came in this morning, the battery seemed to be charged, and we have power once again. Okay, so what we're going to do today is a little bit of a new experiment. We're going to try running the motor off of the battery to seat those brushes while being supplied with power from a DC to DC converter. This particular DC to DC converter that I have has the added benefit that I can plug it into an AC power source because it is a power supply from a computer or server, mainframe, something like that. This device is a Vicor Megapack, which is capable at the moment of putting out 15 volts and up to 80 amps. So the way this works is there are a bunch of modules that are all 5 volt 40 amp modules that you plug into this thing, and the way I have them wired up is that they're in parallel with 2 modules each, which are then wired in series with each other, giving us our total of 15 volts and 80 amps. This is the pack positive, this is the pack negative, and that is wired in at the moment to an Anderson 50 amp connector, which should be sufficient for this particular need, which is then hooked to the battery. On the other side of the Megapack, we have its voltage input, which is hooked up to this computer power cord, standard kind of a thing, which is then ready to be plugged into the wall in a standard 115 volt 15 amp or 20 amp outlet. So what's interesting about this particular unit is that it can run off of DC or AC and is very versatile. So anyway, we are going to use that to try to keep the battery topped off. So what this experiment is all about is trying not to blow that unit up in the process. My theory is that if I first spin the motor up using the battery without the DC-DC converter plugged into the wall or on, then I plug in the Vicor and it should keep the battery topped off while the motor continues to go forever and ever. That's the theory. Now the motor may spin a little bit faster when I plug in the Vicor because we'll be pulling 15 volts we'll be putting into the motor rather than the 12.8 max from the battery, which likely dips down quite a bit as soon as you put a load on it. So we'll see what happens. The Vicor may shoot out fire. Could happen. I guess we'll know in a minute. Okay, so we're going to go ahead and first I want to show you what happens when you plug in the DC to DC converter. Specifically, how much noise this thing makes. So it's not terribly loud in the grand scheme of things, but when you have it in a completely silent electric vehicle, that loud fan noise really bugged me, and so that is why it's not in my car, even though it is a superior DC to DC converter to anything else that I've found. So anyway, that's what that does, putting out a little under 15 volts. Last I measured, I think it was like 14.8 or something. But so what we're going to do for this is plug in, or hook up, the motor, get that spinning. There's that big surge and that inductive load. now that we're going at a good clip, we're going to plug in the DC to DC converter and hopefully no fire. So I heard a slight change in pitch on the motor as it spun up a little bit faster with that 15 volts coming from the DC to DC converter. And I can hear the fan from the DC to DC converter even over the motor, kind of just in the background there. So it all seems to be working. I'm going to monitor the temperature on the Vicor Megapack and make sure that it doesn't overheat or shoot fire out the back. But otherwise, I'm hopeful that maybe this will keep the motor spinning for as long as we need it to seat those brushes. Anyway, I'll be back. Well, as they say, it seemed like a good idea at the time. At least it did to me. Probably an electrical engineer would think otherwise and call me stupid for trying this experiment, but hey, you live and learn. So as it turned out, the battery was drained once again down to completely empty, and at some particular state of charge, I'm not really sure what that was because I wasn't monitoring it very carefully, but the Vicor wasn't able to keep up with the load, and 2 of the 5-volt 40-amp modules appear to have blown. I don't know if smoke poured out or anything. I wasn't out here in the garage watching it at that moment, so video lost for all time, as it were. Anyway, so the 2 modules on the extreme right-hand side of the Vicor, which are the pack negative side, if that makes any difference, are the ones that are no longer producing any voltage. The other 4 modules are still producing 5 volts. I'll have to take them apart, disassemble it, and see if the individual modules are both producing, or if it's just one of them is working and the other one's dead, and because they're wired in parallel, they look like they're both producing the 5 volts. But regardless, I managed to kill it and do damage to the unit. Perhaps the casing is still okay, the power supply portion, maybe just by replacing a couple modules I can get it working again, but clearly it's not suitable for this particular application of trying to run a motor on it. So I guess we'll have to try something else and see if we can get these brushes seated eventually.